We continue with factoring polynomials, and I will explain the remaining two cases, which are factoring by grouping and factoring trinomials of the form ax squared plus bx plus c. I'll start with factoring by grouping. When do I use this technique? Whenever I have more than 3 terms, then I should consider factoring by grouping as an option. That's the first condition. The other condition I will explain once I solve the questions. Let us start with example number 1. In example number 1, I have 3x to the power of 3 minus 9x squared plus 4x minus 12. So I will factor the first two terms and the second two terms separately. Thus, I factor the first two terms by taking a common factor, which is 3x to the power of 2, and I am left with x minus 3. So that's regarding the first two terms. Plus, I do the same thing for the other two terms, and the common factor here is 4, and I'm left with x minus 3. Now, the other condition that I mentioned is the following. How do I know that the grouping technique will work? I must have another common factor among the grouped factors. In other words, if you look at the expression here, you will find that there is a new common factor, which is x minus 3. This is how I know that the grouping technique has worked. Otherwise, I have to look for another technique. So, I take out the x minus 3, and what is left? 3x squared from the first term, as well as 4 from the second term, and that's the final answer. Let us do another example. Again, same story. For the first two terms, I have 5y as a common factor, and I'm left with 3x plus 5a. For the other two terms, we have 30 and 18, and the common factor here is 6 as well as x. What is left? From the first term, I have 5a, and from the second term, I have 3x. Now, there's something very important here. Whenever I take out a minus, I must change the signs of the remaining factors. So the minus here changes into plus, as well as this minus, it has changed into a plus. So please do not forget that many students forget to change the signs when they take a minus as a common factor, and everything turns out wrong. So let's see if the grouping is going to work here. Yes, it will work because we have 3x plus 5a as well as 3x plus 5a. So another factor has popped up. So I take it out, and I am left with 5y minus 6x, and this is the final answer. Let us do one more example. So the first two terms have x squared as a common, and I'm left with x minus 1. What about the second two terms? Well, we have minus x plus 1. There is no common. But the trick here is that I have to factor a minus so that I'm going to change the signs inside, and by doing this, I will end up with a new common factor. So the trick again is to take out a minus. The common factor is x minus 1, and I am left with x squared minus, there is nothing left from here, which means I have to put 1. Now, is that it? Well, no, because x squared minus 1, that's a difference of 2 squares. So I must proceed, otherwise it's still incomplete. So it's x minus 1, and x squared minus 1 gives me x minus 1 times x plus 1. That is the final answer, and it's better to end up this problem with writing it as x minus 1 squared, because we have 2 of this factor, and x plus 1. Regarding the other case, which is factoring trinomials of the form ax squared plus bx plus c, we have two cases. The first case is when a is equal to 1, and when a is equal to 1, the trinomial will look like x squared plus bx plus c. And the other case, which is the more general case, where a is anything other than 1. So how do I do that? Here I have to apply the idea of the sum and product. Always keep in mind, whenever you have x squared plus bx plus c, the first step is to look for two numbers whose sum is equal to b and whose product is equal to C. That is always the case. So always I have to first find two numbers whose sum is equal to B and whose product is equal to C. For example, in exercise 1, we have x squared plus 2x minus 15, which means I have to find two numbers whose product is negative 15 and whose sum is equal to 2. I list all the cases where the two numbers have a product equal to negative 15 and then look for those whose sum is equal to 2. So let us construct a table, and we always start with the product, then the sum. So what are the possible numbers whose product is negative 15, or what are the possible integers whose product is negative 15? Let us start. We have negative 15 and 1, as well as 15 and negative 1. We also have 3 and negative 5, and finally we have negative 3 and 5. These are all the possible cases for the integers whose product is negative 15. Now let us find the sum. For negative 15 and 1, the sum is negative 14. For 15 and negative 1, the sum is 14. 3 and negative 5 give me negative 2. And finally, negative 3 and 5 give me 2. Now which pair match with our exercise? It is the final pair. So the numbers I'm looking for are negative 3 and 5. Therefore, I go back to the question. So I write x and x. Then, what is the first number? It's negative 3. I write it here. What about the other number? It's positive 5. I write it here. Of course, if you want to verify your work, we just expand this expression, and eventually I'm going to get x squared plus 2x minus 15. Let's do another example. So we have x squared minus x minus 42, which means I have to look for two numbers whose product is negative 42 and whose sum is negative 1. Let us list all the possibilities. So we have negative 42 and 1. We have 42 and negative 1, 21 and negative 2, negative 21 and positive 2, 6 and minus 7, and finally negative 6 and positive 7. And the corresponding sums are negative 41, 41, 19, negative 19, negative 1, and positive 1. And the pair which matches with our problem is this. Therefore, the final answer becomes x plus 6 multiplied by x minus 7. Now, let's do this exercise. I want to show you something here. So the product is 8 and the sum is negative 1. Let us list everything possible here for the product to be 8. And the corresponding sums are 9, negative 9, 6, and negative 6. So here, it seems that no pair matches with our exercise. What does this mean? This means that we cannot factor this polynomial, and we call this polynomial irreducible. So this is called an irreducible polynomial, or we can call it a prime polynomial. This means that it's not always possible to factor trinomials. We might end up with an irreducible or prime trinomial as this question. Now we arrive at the more general case where a is not equal to 1. So, if I have ax squared plus bx plus c, again, I'm going to use product and sum. But here I have to look for two numbers whose sum is equal to b. So the sum is just the same, doesn't change. However, the product is not only c, it is a times c. So the product must be a times c. Now this is a more general case. In the previous case, it was the same thing, but since a was 1, it's not necessary to say that the product is a times c because a is always 1 and 1 times c is c. So this is why we just say that the product has to be c. Now we repeat the same story. So we have to look for two numbers in the first question where the product is 6 times 2, and that is 12. And the sum is b, and it's negative 7 in this case. So this is the table, and what we're looking for is the final pair, which is negative 3, negative 4, and negative 7. Now there's more work to do here. It's not only product and sum. In the case where a is not equal to 1, other than finding the product and the sum, we must factor this trinomial using grouping. How would I use grouping? Let me show you. I go back to my question. I copy the first term, so it is 2x to the power of 2. Now negative 7x, I split it up into minus 3 and minus 4. So negative 7x is negative 3x minus 4x. Plus 6, I just copy it as is. So I repeat. I copy the first term, copy the last term, and split the middle term into the sum of the numbers that we have chosen. Then we have 4 terms, and it makes sense that grouping is a possible technique here. So we factor the first 2 terms, which means I take out an x. For the other 2 terms, I take out 2. So 2x minus 3 because I took out a minus, so I have to change the sign. And yes, it worked because another factor popped up. So this is equal to 2x minus 3 multiplied by x minus 2. Now let us do one more question for the general trinomials ax squared plus bx plus c. So I have to look for 2 numbers whose product is a, which is 15, times c, that is a negative 6, that is a negative 90, and whose sum is b, which is negative 27. All right, so this is the table of all the possibilities. The pair which matches with our exercise is this one, where the sum is equal to negative 27. Thus, I go back to the question, so this becomes 15x to the power of 2. I copy the first term. I also copy the last term. What about negative 27? I write it as negative 30 plus 3. Negative 30x plus 3x, and then continue with grouping. So for the first 2 terms, I take out 15x, and I'm left with x minus 2, plus for the other 2 terms, I take out 3, and I'm also left with x minus 2. It works because another factor popped up, so that is x minus 2 multiplied by 15x plus 3. Here I have to be careful because another factor pops up here, which is 3. So the final answer becomes 3, and this becomes 5x plus 1. And of course, I copy the x minus 2, and this is our final answer.